Oh, I want to welcome you to Eko Learners Support for WAEC and NECO. My name is Odusatulokwe Joseph. I'm going to be your instructor for this particular class. So I want you to just sit down, sit back, and let's enjoy ourselves together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
What are we here for? I need to let you know that you need a special knowledge to have a better understanding of what we want to talk about. And the knowledge you need is basically on, see what's going on here. Yes, I hope you can see that is a chemical reaction. So what happened? Good. You need to understand that there must be a reactant before you can have a product. So what happened to the reactant? The bond between the what? The reactant molecules must be broken down. And after broken down, they must what? Rearrange again to form a new product. And this is essential in what we want to talk about today. So can we go into the class proper? Oh, good. So let's go together. Before I proceed, I would like to share the behavioral objective with you. So be able to follow me. Yes. Step by step, line by line. Good. At the end of the class, we be able, one, to test for fats and oils. Two, to explain the cleaning action of soap. We all use soap at home. We want to know how that particular soap help in cleaning the dirt on our clothes. So let's go into the what? Into the topic proper. Well done, guys. I want to show you this video. So let's watch it together and see what actually happened when you apply soap in water and you put your clothes to rinse or to wash the dirt from it. You can see, good, the head of the what? Soap molecules. What D is the what? The tail of the soap molecules. That soap you are holding. When you put them in water, this is the formation. So what happened to the head? What happened to the what? The tail. What's the head called? I hope you know. Oh, good. Yeah, somebody's telling me. I won't tell you the answer yet. What's the tail called? Oh, we are going to see all these together. So let's go on with the video. Fine. I hope you can see. It's trying to what? Lift itself. Good. Fine. What's going on? Oh, trying to come together to form. Good. At this point, to form what we call the micelles. Can you say that again? Micelles. Good. So this is the head. The head is called what? Oh, hydro what? Philic. Oh, water lover. Good. Why are they water lover? We are going to talk more about that. And the tail, the white, is called hydrophobic. Oh, good. Called what? Water eater. Good, good, good. So when they come together, what do they form? They form what we call a micelles. Let's go on. Let's go on. Fine. Okay. You can see what they are trying to do there. Yeah, they are trying to move. Yeah, they are trying to move. So what happened? What happened? Look at the dirt. You see the green picture is the dirt. What are they trying to do? Yes. Good. With the help of what? Agitation. Applying force. Using your hand to rub the clothes. What are you trying to do? The mindset will be struggling with the what? The dirt on the clothes in order to remove the what? The dirt. So how does it happen? You are going to enjoy it. Just keep watching. Okay, fine. So let's go into the what? The chemistry of what has happened there. Now, look at it. I called it cleaning action of soap. Sodium what? Octadecanate. Oh, that is a big word for you. Don't worry about that. What you need to know is what? Sodium what? Sterilate as the soap. This, let me apply my pen. Oh. Okay. Okay, good. Sorry about that. Now, what I underline is actually the chemical symbol or the chemical formula word soap. This is the head. This is head. Yes. The head words contains positive and negative words. Ion. Good. So this is the what? This is the tail. What happened? As you can see, the tail is called a long chain what? Hydrocarbon. Basically, they don't contain what? They don't contain iron. Therefore, they are called what? Not polar. Not polar. So why are they not polar? Because they don't contain iron, either positively charged ion or negatively charged what? Ion. Okay, good. Nodes. That is a problem there. So, what do we call them generally? They are called what do you say? Phobic. Say it again. Hydrophobic. Say it again. Oh, good. Hydrophobic. Another word, they are called water ether. Water ether. So why are they called water ether? Because they don't contain both the negative and the positively charged ions. Oh, wonderful. Now the head, what's the head called? What's this particular head? Yes, what's this particular head called? What's the head called? The head is called hydrophilic. Say it again, hydrophilic. That is what? Water lover. That is what? Water lover. Okay, good. And because they contain both positive and negatively charged ions, they are called polar what? Polar what? They are called polar. 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 So what's the essence of the polar? So let me explain. As you can see in the picture here. Good. Look at this picture. This is your what? Your fabric. Example, your clothes. Okay? Maybe your dead what? Plates. What happened to it? This is the oil. Yeah, at this point you need to understand the oil are not polar. Are not what? Polar molecule. When you apply it inside the what? Water that contains soap. Look at what happened. This part is water molecule. This is what we call water molecule. You know what we call water molecule? Basically, water molecule is what? A polar compound. That is, it has both the negatively charged and the positively charged. I hope you are following me. So what happened to the soap? The head of the soap that we called what? Remember? Hydrophilic? Yes. Good. Polar molecules. We go along with the what? With the head of the soap. Fine. Coming together. Now what happened to the tail? The tail of the soap. You remember? Hydro what? Phobic. Hydro what? Phobic. The water what? Ether. That one cannot go with the water. So it will go with the what? Oil. Why? Because the oil is what? a non-polar molecule. Good, get attached. As I earlier said, the video that I showed you, what happened? Then there must be what? Agitation. Now that was going on here. So that's what we call agitation. This agitation is what? With the help of force. That is what brings about scrubbing your what? Your clothes. You are applying force. So the oil on the surface of a what? Clothes can go with the tail of the what? Soap, come together. And the micelle will now try to what? Move it up from the surface. And that was going on here. So after the what? Apply force, what happened? The micelle. So what happened? So what happened? The micelles lift up your oil from the what? From the surface of your what? Clothes. And we are very, very good to go. Extremely good to go. So what happened? You have to what? Rinse. When you rinse, what happened? It gets evaporated and it goes its way. But let me explain more about that for you. I hope you're following me. Let me take my pen and erase all. I need to erase all. Take my pen again. And let me go to the next slide and see what actually happened. Okay, fine. So the polar group, let me take my pen again. The polar what? The group. You know the polar group now? The one on top of the what? Of the soap. And the water is responsible for the formation of what? Oh, emotion. Don't get it confused with what you have in paint. You know we have emulsion paint. You have gloss. Don't mix it up. Yes. So the formation of what? Emulsion in soap, action with water, is as a result of what? The polar group. And what is the polar group called? Hydrophilic. Hydrophilic. Fine. Yes. Good. And the soap mixed with water and the polar head what? Assembled together to form what we call the micelle, which help. You know, the micelle helps in removing the dirt from the surface of the fabric or the plates. Good, as you can see there. Fine, let me go back again. Erase all, take my pen, undo it, and let me go back to the next slide. Now, what happened in this particular case? Let me take my pen again. There's something you need to understand. So, in soap solution, you know, you have water and you have the word soap solution now. So the water has a high surface tension. But what happened to the what? Your soap that you've already dissolved in the water. The soap solution has what we call a low surface tension. So I call it has a lower surface tension on this than the water. Now, if it has a lower surface tension than the water, so what will that one do for the soap? Good. Therefore, the soap dissolves the dirt easily. Look at it. That is, the dirt is the mixture of what? The fats and the oils. Good. Are you following me? I've told you the water has a what? Surface tension. The surface tension of water is high compared to that of what? The soap solution inside the water. And the soap solution has what we call a lower surface tension. What is the lower surface tension of this soap solution doing for the soap? Basically, it helps the soap to dissolve the dirt. Now, the dirt now could be what? Oils. It could be what? Fat. From the mixture. Or what? Oh, so from the fabric. Sorry about that. From the fabric. Now, what happened to the non-polar? Obviously, remember the non-polar. Now, the non-polar is the alkyl group of the what? Of the soap. The one that does not contain both the negative and the positive charge ions. They don't contain ion. What happened to it? It's the one that goes straight to the what? The oil. Because the oil too, it has no what? Positive and negative charge. So they are basically called non-polar molecule. What happened to it? Dissolve. Good. The non-polar greasy what? Dirt. You know the meaning of greasy dirt? Those oily things you have in your what? In your plate. So basically at this point, when you are trying to wash your plates, what comes to your mind? Two things are very important. The hydrophobic and the hydrophilic. The hydrophilic is the what? The water lover. The head, the hydrophobic, is the water what? Eater. The tail, and it's this tail that we call not polar, and it's the one that is going to help in dissolving the what? The oil, which is equally what? Not polar molecules. Hope you're following me. Good to go. Why the dissolves? Yes, why the what? The polar what? Head dissolve the what? In water. Water is a polar, so the polar head of the soap will be dissolved in the water. All these form micelles, which help through the agitation in removing the dirt from the surface of the fabrics. I hope you've gotten that. Oh, good. You are now becoming a good what? Scientist. A chemist. Yes, a future what? Yes, a future what? Problem solver. Let's go on. Okay, fine. I need to erase all. Good. I need to undo my pen. I can move to the next slide. Oh, good. So what's going on here? Oh, you can perceive it. Oh, yeah. A good, wonderful student is what? Washing plate. Then what comes to your mind? You begin to think about chemistry, yes, of this particular solution. So let's see what happens. On the other hand, hydrophilic. I hope you know the hydrophilic now. Good. The ionic what? Head of the soap is not attracted to the grease. Why? The grease is what? It's not polar. Why the what? Hydrophilic is polar. So there won't be any attraction. Then what happened to the grease? But the grease is strongly attracted to the... Yeah, it's not attracted to the grease, but it's strongly attracted to the what? The water molecules. So what is attracted to the water molecules? You might be wondering again, is what? Hydrophilic, because that is the polar. So the polar is strongly attracted to the what? Water molecules. Why? Because the water molecule too is what? A polar. So a polar will attract polar molecules. And what will happen? Non-polar molecules will attract non-polar molecules. So which one is non-polar molecule? The grease will be attracted to the tail of the soap. And what's the tail called? Hydrophobic. Good. When the water is stirred, the grease is slowly what? Released and is completely surrounded by the what? By the soap. Yes. By the soap. And when that happens, you keep imagining, when that happens, the grease is therefore solubilized. This is very, very important. And removed from the what? Yes, from the soap. And removed, yes, from the dish, sorry. Good. And the soap is able to remove, the grease because of the combination of covalent and the what? Ionic bonding. That's very important because these are the questions I'm going to ask you. So why is it possible for the soap to be able to remove the dirt from the what? Or the grease from the surface of the what? Dish? It is because of the two bonds. What are the bonds? The first one is the covalent bond and the second one is the ionic bond. The ionic bond is coming from the what? From the water molecules. Yes, we strongly attracted by the head of the what? Soap. Why the what? The covalent bond is coming from the what? The hydro what? Oh, you remember, hydrophobic, water eater. Good. And what happened? Get attracted to the grease. So the soap, the tail of the soap, get attracted to the grease. All together, come together to form what we call what? A micelle. Then through what? Agitation, you remove the micelle. And what happened? The whole thing solubilize and get removed in the process. By what again? Two bonds. What are they? The ionic bond and the what? Covalent bond. Thank you so much. Thank you so much. So, I need to undo. Let me erase all first. Then let me undo my pen. Okay, fine. I can move to the next slide. So we are rounding up. Forgive me by using so always. I'll culture myself. Oh, good. So I will use so again. Thank you. So we are going to the next slide, which is the test for what? Fats and oils. So if you have to test for fat and oil, there are two things you can do. I want you to do this at home. One is very easy to do. We call it a paper test. Just get a paper at home. Then a drop of what? Oil inside the what? The paper. It forms what we call translucent when look through the what? Through the light. So when the thing spread, it will first form a spread round shape on the paper. Then when you look through the paper from the light, you see what we call translucent. What does it mean? Tells you that oil is present inside the paper. Meanwhile, the second one is basically a chemical test in the lab. It's called Sudan what? Oh, Sudan 3 test. Sudan what? Sudan 3 test. I've explained the first one, very simple. Make sure you do this at home. While the second one, all you need to do, get the reagents with the permission of your chemistry teacher in the lab. The chemical is there. Just get the chemical, bring what? Oil to the lab. And what happened? Add the Sudan 3 to the what? To the fats. What will you notice? You notice one thing. It's called a color change. So there's going to be what? A red color. You are going to observe what we call a red. Oh, sorry about that. I haven't picking my pen before doing that. I won't do that again. Do you get? Okay, fine. So let's move on. So it's from what we call a red. Oh my God. So what's going on with my pen? Fine. It's from a red color, which shows that that thing you brought from home to the lab is a fat. Is that clear? Okay, good. On this note, I want to say, do you have any question? Good. If we don't have any question, let's see what the next slide we ask us to do. Oh my God. So the next slide says, I should thank you for listening, but remember, in case you have any comments, any information, or any question you want to ask me, use the display information to do that. See you in the next class. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.